Okay, so for the mean of this distribution, this is actually, there's an easy way to work this. And instead of using the formula, you have 7 number that have a 1-star rating. So instead of adding up 1 7 times, you can multiply 1 by 7. For the second one, the same thing. You have 4 2-star ratings, so instead of adding 2 up 4 times, you can just multiply. And then multiply, multiply, and multiply. And we get 1575, 121, 170, 161, sorry. And that's the total, our total, like when we add it up, but we have to divide it by how many reviews there were. And there were 11, 31, 40, 50 reviews. So this frequency will tell you the total amount, and when you divide, you will get 3.22. For the next one, it's the same thing. Just multiply each one of these across. You get 4, 42, 24, 80, and 72, and you add those up and you get 222 divided by, how many do we have? Well, 16, 22, 38, 50. So 222 divided by 50 would be 4.44 for your mean. For the empirical rule, 68% of your data points are 1 standard deviation away from the mean. 95% of your data points are 2 standard deviations, and 99.7% of your data points are 3. These are your 3 magic numbers. So when you're doing this, you're going to take, to figure out your, you're going to use your formula here. Mean plus or minus the number of standard deviations, either 1, 2, or 3, depending on the percentage. So on this one, bananas are sold in the grocery store, blah, blah, blah. The mean is 3.54. So label the mean 3.54. Standard deviation is 0.63. And we're talking about 99.7%. The interval that would contain 99.7%. Remember, 99.7% is 3 standard deviations. So we're going to say mu plus and minus 3 times the standard deviations. So 3.54 plus and 3.54 minus 3 standard deviations. So 3 times the amount of the standard deviation, which is 0.63. So if you do that in your calculator, if you do 303.54 minus 3 times 0.63, you should get 1.65. If you do 3.54 plus 3 times 0.63, you're going to get 5.43. Okay, on question 21, part 2, Costco. It says it installs tires. The total time a customer needs to wait to be completed follows a normal distribution, which is important, with a mean time of 106.3 and a standard deviation of 18.5. And we want to know the interval that contains 68%. 68% is 68% of the data points will be 1 standard deviation. So mu plus and minus 1 times the standard deviation. So 106.3 plus or minus 1 times 18.5. And when you do that, you're going to get 87.8. Your smaller number goes first, and 124.8. On the next one, the Major League Baseball averaged 42,019 fans per home game. And the attendance follows the normal probability distribution, so we can use the empirical rule. And the standard deviation is 9,000 per game. And we want to know the interval around the mean that contains 95%. 95% of the data points are within 2 standard deviations away from the mean. So we're going to do the mean plus and minus 2 times standard deviation. So 42,019 plus and 42,019 minus 2 times 9,000. So basically 42,019 plus and minus 18,000. So we would get 24,019 to 60,019. So 68% of the data points will be within that interval. We're going to have to get do the normal distribution, the probability, and it's continuous, and the mean is 92.1, and the standard deviation is 3.8. And we want to know the probability that the score on the next round will be more, the probability that x will be greater than 90. So the first thing we have to do is get our z value, or our z-score, which is x minus the mu over the standard deviation. So 90 minus 92.1 divided by 3.8. So our z value is negative 0.55. So let's look at the normal distribution. We know the curve, the whole area under this curve is 1. This is important to understand, that everything up under here will add up to 1. Now, when we first started this problem, the mean is going to be in the middle, and I'm going to draw it like that, and we know the mean is 92.1, and we want to know the probability that it's greater than 90, okay? So we want to know the probability of this, everything to the right of 90. But we don't look 90 up in the table. We have to convert it to a z-score. When we convert it to a z-score, the mean turns into 0, and the z-score is the number of standard deviations away from the mean. So because it's negative, it means it's 0.55 standard deviations to the left. Now, you're going to use a table, and if you go into your bookshelf, you have an appendix, and you're going to scroll down and find, and you have to keep scrolling, and there's probably a table online you could use, and we're looking for negative 0.55. Now, this is positive, and okay, here's the negative, and the first column is 0.0, so 0.50, and then let's go to 0.50, and then this is 0.3085 is 0.50, 51, 52, 53, 54, 55. So that would be 0.2912 on your table. Now let's go back and look at our problem. When we look it up on the table, it's always going to give us the less than side. So I just found out the probability that x is less than 90 is 0.2912. So if I know that the pink and the blue add up to 1, To find the greater than 90, I'm going to take the number 1. You always do this if you want greater than. Let me put that. 1 minus 0.2912 equals 0.7088. So it's important if you're looking for greater than, you're going to do 1 minus whatever you get in the table. If it's less than, then the number in the table would be your answer. So the probability that his golf score is more than 90, there's a 70% probability of that. Okay, on the next one, bananas are sold at a grocery store and consist of 4 to 8 bananas per bunch. Suppose the weight of these bunches follow a standard normal distribution with a mean of 3.54 pounds and a standard deviation of 0.63. What is the probability that a randomly selected bunch of bananas will weigh more than 3 pounds? So first we need to get our z-score. Remember, it is x minus your mean divided by your standard deviation. So x is 3. Let me write that up there. Minus 3.54 divided by 0.63. And so that would be negative 0.86 that we have to look on the table. Now remember, that was not a good curve. Remember, our mean is in the middle. When it's normally distributed, our mean and our median would be the same. So there's our mean. And then negative 0.86 is going to be, let's start with the 3. Now, we want to find the greater than side. Remember, we know everything under there equals 1. And remember that when you change it to a z-score, the mean is 0 because it's 0 standard deviations away, and your z is negative 0.86, so less than 1 standard deviation to the left. Now when we go to our table, it's going to show us the probability of it being less than 3. So we're going to have to get the greater than side, we're going to have to say 1 minus what we look up on the table. You're looking up negative 0.86 on the table. So if we go to negative 0.86, here's 80, 81, 82, 83, 84, 85, 86, 0.1949. So 0.1949 is the less than side. So the greater than side is going to be 1 minus 0.1949. So if you subtract 1 minus 0.949, the area of the pink, or the probability that x is greater than 3, is going to be 0.8051.